All right, so we're going to talk about hypothesis testing. So a hypothesis is a claim about a population parameter or some other characteristic of a population. A hypothesis test is a standard procedure for testing whether a claim about a population parameter or other characteristic of a population is supported by the available evidence. The null hypothesis, or H sub naught, is the starting assumption for a hypothesis test. And although other forms are possible, we consider only null hypotheses that claim a specific value for the population parameter, and therefore take the form of an equality. The H sub naught, which is the population parameter, equals the claimed value. Now, the alternative hypothesis, or H sub A, is a claim that the population parameter has a value that differs from the claimed value in our null hypothesis. Both the null and the alternative hypothesis should always be formulated before a sample is drawn. And we always consider, or I think there's from the population, we always consider at least two hypotheses in any hypothesis test. So the possible outcomes of a hypothesis test would be that a hypothesis test always begins with the assumption that the null is true. We then test to see whether the data gives us reason to think otherwise. As a result, there are generally only two possible outcomes to a hypothesis test. We reject the null, which means we don't have enough evidence to support it, the alternative hypothesis, or we not reject the null, in which case we do not have enough evidence to support the alternative hypothesis. So in this one we have support, we reject the null, we have enough evidence to support the alternative, or not reject the null means we do not have enough evidence to support the alternative. Notice that accepting the null hypothesis is not a possible outcome, because the null hypothesis is always the starting assumption. So it's either reject or not reject the null. So drawing a conclusion from a hypothesis test, how do you decide whether the sample results should lead us to reject or not reject the null hypothesis? The answer comes down to deciding whether the sample result was likely or unlikely to have occurred by chance if the null hypothesis is true. For testing it, the first step would be to formulate the null and alternative hypothesis, each of which must make a claim about a population parameter, such as the population mean. The second step is to draw a sample from the population and measure the sample statistics, including the sample size and the relevant sample statistics, such as the sample mean. Step 3 is to determine the likelihood of observing a sample statistic, or at least as extreme as the one you found under the assumption that the null hypothesis is true. Step 4, decide whether to reject or not reject the null hypothesis based on your chosen level of significance. Usually that's going to be a 0.05 or a 0.01 significance, but there are other ones used. All right, so let's do some examples. We are going to formulate the hypothesis. This is the part where most students struggle, so these are a good thing for us to practice. So in each case, state the null and alternative hypothesis for a hypothesis test. Nissan claims that the Leaf, an electric car, has a mean range of 110 miles between charges. A consumer group claims that the mean range is less than 110 miles. All right, so let's go write our null hypothesis and all our alternative hypothesis. So this is 9.1, example 1A. So remember that the null hypothesis must state that the population mean is equal to a specific value. So we're going to recognize the null hypothesis as the advertised claim that the mean range for the cars is 100%. So our null hypothesis, which is our h sub naught, h sub 0, is equal to our mu of 110 miles. Okay, so mu, that population mean, is equal to 110 miles. Now the alternative hypothesis which will be our h sub a, is mu is, they said the leaf was less than 110 miles. So less than 110 miles. Okay, that's what the consumer group said. So these are your two hypotheses that you're stating. We're not proving them, we're not testing them, we're just figuring out how to write the hypothesis. All right, part B. We have a medical researcher wants to test the claim that healthy adults have a mean or average body temperature less than 98.6 Fahrenheit. All right, well, our null hypothesis which will be our h sub naught, is that our mu is equal to 98.6 degrees Fahrenheit. But the alternative which is h sub a, says that it is less than 98.6 degrees Fahrenheit. So this would be our h sub naught. This will be our alternative. All right, let's do one more. The quality control manager at a manufacturing company claims that the proportion of defective transistors is greater than 0.03. So what's the null hypothesis? It will be equal to the 0.03. So we'll have our null hypothesis is that our mu is equal to 0.03, and our alternative hypothesis will state that our mu, in this case, they said that the proportion of defective transistors is greater than, so this time we'll have a greater than symbol, 0.03. That's all you've got to do. Now, so this comes on the heels of what we did with the Chapter 8 material. So I've created, you don't have homework in those, but I created an activity for you. You're going to approximate the margin of error and 95% confidence interval. We did examples of 8.1 with that, or not 8.1, 8.2. And then in each case, state the null and alternative hypotheses for a hypothesis test. Sorry, a little bit of a tongue twister. So you've got two examples. You're going to do similar things to what we just did. All right, so that'll give you some practice with those. And that's the last of the material for our course. All you have left now is the final exam.